Hello everyone, welcome to the fifth video lecture of class 9 science. So we are dealing with our first unit measurement. So in the last video we have studied about one of the instrument that is vernier calipers, and we were even introduced to one more instrument named screw gauge. So in this video lecture we will be learning more about screw gauge, as its description, pitch, least count, zero error, and how actually we measure using the screw gauge. So screw gauge is an instrument that can measure the dimensions up to 0.01 millimeters. Okay, so that means the least count of the screw gauge will be generally 0.01 millimeter. Okay, screw gauge is widely used for precise measurement of small objects like diameter of the thin wire and thickness of thin metallic plates. Okay, very thin, very small lengths can be measured using the instrument named screw gauge. Okay.
Screw gauge consists of U-shaped metallic frame. To one side of this U-frame, a long hollow cylindrical tube with a nut inside it, and the inner side of cylindrical nut contains a uniform thread cut in it. On the other side of U-frame, a fixed stud S1 with a plain face is attached. A screw S2 is fitted in the cylindrical nut. One side of the screw S2 has a plain face similar to that of stud S1. The faces of S1 and S2 are plain and parallel to one another. The other end of the screw S2 carries a milled head edge attached to a cap C with a sloping edge. When the head edge is rotated, the screw moves to and fro in the nut. The milled head edge is provided with a safety device M to rotate the head edge. When the object is held between the stud S1 and the screw S2 and the head edge is rotated using the safety device M, it produces the crackling sound when optimum pressure is applied on the object. The outer surface of long cylindrical nut consists of a thick horizontal line P parallel to the axis of cylindrical tube. This line P is called index line. Along the index line, a scale is graduated in millimeters. This scale is called pitch scale. On the sloping edge of the cap C, a circular scale is graduated which consists of 100 or 50 equal divisions. This scale is called head scale.
Here is the picture of a screw gauge with all the parts labeled. So you can go through this. So this picture is also available in your textbook. So kindly go through it. So the next one is the pitch of the screw gauge. The pitch of the screw is the distance moved by the tip of the screw for one complete rotation of the head. We have seen in a screw gauge there are two scales. One is pitch scale, another one is head scale, right? The head scale can be rotated. So what is the distance moved in the pitch scale when a head scale completes one rotation? When you turn it and you make one complete rotation, what is the distance moved in the pitch scale? That will give you the value of pitch. So pitch of the screw can be calculated as distance moved by the pitch divided by number of rotations by head scale. So usually the pitch will be 1 millimeter or 0.1 centimeter. So let us see in detail how actually the pitch is calculated.
the circular scale is rotated to bring the zero mark on the reference line. The linear scale or the pitch scale reading is noted down. We count the number of divisions on the linear scale completely uncovered by the cap. Here it is 2.0 millimeters. Now we rotate the screw 5 times. When the zero mark of the circular scale again arrives at the reference line, one rotation is said to be completed. We again note down the linear scale readings after 5 rotations. It is 7 millimeters. We get the linear distance moved as 7.0 minus 2.0, which is 5 millimeters. Thus, pitch can be calculated as 5 millimeters divided by 5, which is 1 millimeter.
So after studying the pitch, the next thing which we are going to learn is the least count. So we know that the least value a measuring instrument can measure is called the least count of that instrument. So how actually we calculate the least count of a screw gauge? In case of screw gauge, it is calculated as the distance moved by the tip of the screw for a rotation of one division on the head scale or the circular scale. The head scale is also called as the circular scale. So how actually we calculate? Is using this formula. Least count is equal to pitch divided by total number of divisions on the circular scale.
Now, the circular cap is divided into 100 divisions. Then, if the cap is moved through one division, then the distance moved is 1 by 100th of the pitch, which is the least count of the screw gauge. Pitch divided by number of divisions on the circular scale is equal to 1 divided by 100 mm, which is.
So we have calculated that usually the least count will be equal to 1 divided by 100, that is equal to 0.01 millimeter or 0.001 centimeters. Okay, so that was about the least count of the screw gauge, how actually we calculate the least count of the screw gauge. The next thing which we are going to study is the zero error. So when the movable stud of the screw and the opposite fixed stud on the frame are brought into contact, that is as given in the picture, you can see both the studs are in contact, right? Yeah. So which are the two studs? One is the fixed stud here, another one is movable stud here. So these two, when they are in contact, at that situation, if the zero of the head scale coincides with the pitch scale axis, then there is no zero error. That means we know that there are two scales, one is pitch scale, another one is head scale. When the zero of the head scale is coinciding with the axis of pitch scale, then we say that there is no zero error. If not, then we can say that there is some zero error. It can be either positive zero error or it can be negative zero error. These zero errors are either due to manufacturing errors or increase in the wear and tear of screw threads. So whenever we use the instruments, we unknowingly damage it sometimes by rotating it more or continuously rotating. So what happens, there will be a wear and tear in the screw threads, so which will actually damage the given screw gauge. So due to these reasons, there will be some zero error. So these zero errors can be corrected by proper analysis of zero error and zero correction. Okay, the first one which we are going to study is positive zero error. If the zero of the head scale lies below the pitch scale axis, so you can see here this one is the pitch scale axis. So this this one is the pitch scale axis, and 0 of the head scale is below the axis, right? Here is the 0, here is the 0, and here is the pitch scale axis. So if the 0 is below the pitch scale axis, we say that the 0 error is positive. Okay, so if it is positive, 0 error can be calculated as plus, because it is positive, n into LC. LC is least count. What is this n? Where n is the head scale coincidence. Here it is 5. The number which is coinciding with the axis of the pitch scale. The head scale division which is coinciding with the pitch scale axis. Here it is 5. Right, 5 is coinciding with this blue line, so we say that 5 is the division which is coinciding with the axis of the pitch scale. So 0 error will be plus 5 into 0.01 millimeter, which is equal to 0.05 millimeters. Okay, so we know that if the 0 error is positive, the correction will be negative. Therefore 0 correction is minus 0.05 millimeters. So this is about how actually we calculate the positive error and corresponding 0 correction. Okay, the next one is negative 0 error. So in this case the reverse thing happens. The previous case we have seen that the 0 of the head scale is below the pitch scale axis. In this scale, the 0 of the head scale will be above the pitch scale axis. Here it is clearly seen. This blue line is the pitch scale axis, this one. So here the 0 is above the pitch scale axis. In the previous case it was downstairs, like it was downwards. So now in this case the 0 is above the pitch scale axis. Therefore here the 0 error is said to be negative. So here in this case the 0 error is calculated as, since it is minus, we put a minus 100 minus n into least count. Whenever we calculate negative error, we go backwards. Even in the case of vernier calipers also we have seen the coinciding division we will find, and we will count from backward, right? From 10 onwards we will count. Here also the same thing, from backwards we are counting. That means from the 100th division we are counting. That's why the equation will be 100 minus n. 100 minus n into least count. Here the coinciding division is 95, or if we are counting from backwards it is 5. So always it is difficult to count from backwards, so what we do is 100 minus that number will actually give you the value if you count from backwards. So the 0 error will be minus 100 minus 95, because n here is the coinciding value, that is 95. So into least count, that is 0.01. So minus 5 into 0.01, which will give you minus 0.05 millimeters. So the 0 error is negative, that means the 0 correction will be positive, that is plus 0.05 millimeter. So this was about no 0 error, positive 0 error, and the negative 0 error. So all these things we have even studied in the case of vernier calipers, except the pitch. So all other things like description, even in the case of vernier calipers also we have seen its different parts and what are its uses. So how actually different parts are used for different purposes. Here also in the case of screw gauge we have studied its description, what shaped frame is present, which are the two scales present in screw gauge, everything, the description in detail we have studied. After that, in the case of vernier calipers, we studied about zero error, least count. And in the case of screw gauge also, we even learned about zero errors and then the least count. One extra thing which we studied in this case is the pitch. This was about no zero error, positive zero error, and the negative zero error. So till now we have studied the vernier calipers and the screw gauge. So both, if you see, they have got some similarities. I mean, in the case of its way of study, that is, first in both the cases we studied about their description, that is different parts and how different parts are used for different purposes. And then they both have got two scales in them, that is, in the case of vernier scale, vernier calipers, it has got the main scale and the vernier scale. In the case of screw gauge, there are a head scale and the pitch scale. After studying about the description, we went on to study the least count. So there the least count we studied in one way. Here before learning the least count, we even studied something about pitch, a new terminology. Then after that we saw that both the instruments will have some kind of an error called zero error. It can be either due to manufacturing defect or due to the mishandling. So wherever there is an error, we have to make sure that that error is not making any difference in our values. So for that purpose, we analyze the zero error and we carry out a correction procedure in both the cases. So in the both the cases, we have calculated or seen different types of errors, like when there is three different situations, that is no zero error case, positive zero error case, and negative zero error case. And one more similarity is that in both the cases, if the zero error is positive, the correction will be negative, and if the zero error is negative, the correction will be positive. So this was about the instrument, how the basic requirement for an instrument. Okay, so next we'll be seeing how actually we can measure the smallest lengths using the screw gauge. So first we need to determine the least count, zero error, and its zero correction. Okay, this is, they are the preliminary. If you go even for the case of vernier calipers, first thing you have to find out is its least count, its zero error, and its zero correction. Then what we do, we have to place the object between the measuring faces. Okay, that means between two studs. Okay, so after placing them, we have to rotate and make sure that the object is firmly held between the studs using a ratchet. We should not over rotate the head scale. So there is a protecting part given named ratchet, so we have to carefully use that. Then after that, we need to read the pitch scale and the head scale. So for example, I have taken it as pitch scale reading as 3 millimeter. So pitch scale reading can be in symbolic form or in short form, you can call it as PSR. And I'm taking that the fifth division of the head scale is coinciding with the pitch scale axis. Okay, therefore the n will be equal to 5. So here is the formula to calculate the total reading, which is equal to PSR, that is pitch scale reading, plus n, that is the coinciding head scale division with the pitch scale axis, into least count plus its zero correction. If the zero correction is negative, you have to put negative. If the zero correction is positive, you have to put it as positive. Okay, then here, according to the example which I have taken, the PSR is 3 millimeter, then the least count is 0.01 millimeter, and n is 5, and the correction is 0.05 millimeter. So it becomes 3 millimeter plus 0.1 millimeter, which will be equal to 3.1 millimeter. So the object the diameter or the thickness of the any object which is placed between the studs, two studs of the screw gauge will be equal to 3.1 millimeter. So this is how we calculate the length, that is diameter of any thin wire or thickness of any thin plate using the screw gauge. Okay, so there is an assignment with 5 small questions. So it includes the question even for your vernier calipers also, because the last week I was not able to give you any assignment. So here is it. So please do this homework, I mean assignment, after going through the video and after reading the whole lesson. That means vernier calipers and the screw gauge. Thank you.